In this video, we're going to go over how to simplify these rational expressions. So I'm going to look at the first one where it says x squared plus 2x minus 3 all over x plus 3. So first thing I'm going to do is I see that I can factor the numerator. So there's no value in front of x squared, so I assume a is 1. So when a is 1, all I have to do is find a pair of numbers that multiplies to -3 but add to 2. And if I think about those numbers, I know I need to have a positive and I need to have a negative in order for them to multiply to get to be a -3. So I could do 1 times -3, or I could do -1 times 3. But I also need to make sure that they add up to a positive 2. 1 plus -3 gets me -2. -1 plus 3 gets me a positive 2. So this is the combination that I like. So to factor, it's going to be x minus 1. And the second factor would be x plus 3 since it's positive. I can't factor x plus 3. So I'm just going to bring that along. And we pretend that there are parentheses around it because we're looking at it as a whole unit. I notice that x plus 3 appears in my numerator and my denominator. Since they're common factors for the numerator and denominator, if I divide through by them, I would get 1. X plus 3 divided by x plus 3 is 1. So I can cross them out, make them 1 if I want. Now it's x minus 1 times 1. Well, 1 times anything is itself. That's x minus 1. And I'm left with 1 in my denominator. So again, anything over 1 is itself. So the simplified rational expression is x minus 1. The only value that x could not be is x cannot equal 3, or -3, sorry. Because if I had substituted -3 into my problem, I would be dividing by 0, and that is not possible. In the second problem we have here, s squared minus 4s minus 45 all over s squared plus 2s minus 15, we have a little bit more to do because both the numerator and denominator can be factored. So for the numerator, again, I'm looking for a pair of numbers that multiplies to a -45, but that adds to -4. All right, so if I think of -45, the first thing that pops into my head is -9 times 5. 9 times 5 is 45, so -9 times 5 is -45. And -9 plus 5 does equal -4, which is what we're trying to get for the b. So when I factor this, I know -9 and 5 are important. So I have x minus 9 and x plus 5, because again, you take those signs. Now I have my denominator. My denominator can also be factored. I'm looking for a pair of numbers that multiplies to -15, but adds to 2. All right, I know that those numbers are going to be 5 and -3. Because 5 times -3 is -15, and 5 plus -3 does equal 2. So again, I'm going to write those values down here. I have x plus 5 since it was positive, and I have x minus 3 since it was negative. Again, I look for things that are the same in the numerator and denominator. Here I have x plus 5. Here I have x plus 5. If I divide through by the same values, they equal 1. And now I can write my final problem. X minus 9 times 1 is x minus 9. And 1 times x minus 3 is x minus 3. This is the simplified form. And the only value here that x can't be, it can't be 3, because if I substituted 3 in, 3 minus 3 would be 0. And as we know, we cannot divide by 0.